Welcome to this 1-hour webinar, Building, Operationalizing, and Monitoring AI Workloads with Trust and Transparency. My name is Laura, and I'm one of the community managers at the Coursera community. And that URL is www.coursera.community. Seppi is a data scientist, machine learning engineer on the IBM Data Science Elite team based in San Francisco. After completing her PhD at the Center for Pattern Analysis and Machine Intelligence at the University of Waterloo, she started her journey as a big data and analytics consultant. Seppi joined IBM as an open source solution engineer, working for IBM Canada for 2 years, where she was honored to be awarded the Best of IBM 2018. She really enjoys being on the Data Science Elite team and applying AI in real-world applications to help customers on their data science journey. Anna Maria is a data scientist and AI evangelist on the IBM Data Science Elite team. She works with clients globally, helping them become successful on their data science journey. She joined IBM over a year ago and held previous positions as a general manager and EMEA regional manager for large international organizations, effectively using data to drive business decisions while managing and growing the business. Being a lifelong learner, her studies are varied and diverse, and she holds degrees in transport engineering, psychology, and computer sciences. In her everyday job, she utilizes her skills in machine learning, Python, R, Sparks, and big data analytics. So welcome, Seppi and Anna Maria. Take it away.
Thanks, Laura, and thank you very much for your introduction, and hello to everybody. First, let us start sharing our screen and introduce you to the agenda. Okay, great. Just 1 second. All right, so on our agenda today, on the next slide, we are going to speak about AI. Yes, this is the one. AI for the business. And after that, we are going to go into details on the data science workflow, how to build a model, how to automate it, how to deploy the model and manage and monitor the deployed model. After that, we are going to look into some data science use cases that our team resolved. These are going to be real life cases. And then eventually we are going to go into the AI challenges, and we are going to speak about regulations, ethics, and bias mitigations. So now let's skip on to our first topic, AI for the business. All right, so first of all, why do we need AI for the business at all? So with the new computing technologies and the extraordinary amount of data we collect, it's no longer feasible for us humans to process all the information. And in fact, with such high amount of data, machines are more capable to pick up on relationships, patterns than we humans are. So that's why AI can actually help us unlock the value of data in many new ways. For example, with machine learning and predictive modeling, we can predict a future outcome. And if we already predicted this outcome, then we can stop there a little bit and think about it, that is this really the desired outcome that we wanted? If not, then we can still make changes. We can change the trajectory. And this is where decision optimization and prescriptive analytics comes into the picture. So with prescriptive analytics, we can prescribe steps for the business to make new steps and get to our desired outcomes. And we can also make decisions automated and processes automated in order to be more efficient. And we can also reimagine the entire business model based on all the new technology that is available to us. So AI for the business can surface hidden intelligence to transform how our business operates. So on the next slide, I'm gonna tell you a little bit about how we can put AI to work for our business. Where first of all, we need a use case. if the organization just started out on their journey towards AI, then this use case does not need to be something overly complex and requiring high investment, etc. It needs to be something very simple, just a quick win that can actually prove the concept of AI to the organization. And then later on, the new use cases can be added. So technically one use case at a time, iteratively, in an agile fashion, we can start building up our AI portfolio. All right, so if we had our use case already, then the next step is that we need to support it with the data, because AI builds on data that it learns from. And this is where many organizations actually have problems, because data lives in silos. Sometimes organizations don't even know that they have the data or where they store it. Or sometimes they collect data that is not exactly useful for them, and they don't collect the data that would be useful for them. So that's why thinking about data strategy is absolutely crucial. And then the next step, when we already have our data, someone needs to build a solution or work on that data. And this is where the skill sets come into the picture. So building an open and collaborative data science team and environment is really key. Then the next step is really these data scientists will need some tools. And on the market, with the latest AI technologies and techniques, there are so many solutions where you can actually build out your desired AI product or solution. And once this solution is built out, then the next step is that it needs to be integrated into the business processes, workflows, and make it available for the user. So effectively, putting AI to work can be really done case by case, one use case at a time. Now, I also wanted to talk to you about the AI ladder a little bit, which is on the next slide. You might have heard this expression from us, IBM, many times already. So I just wanted to elaborate on this, what the AI ladder is. So the AI ladder includes all the steps that an organization has to take in order to get to an AI future. So what are these steps? First, we need to collect the data. So no matter where the data resides, whether it's in a multi-cloud environment or it's on premises, it needs to be collected and made available for the users for processing. So once we collected the data, then the next step is that the organization needs to know what is where, which can be done by effective cataloging, and also who can access what. And that's by utilizing dynamic data access policies and enforcement. Then when we have all the data, we can proceed with analyzing it. And with advanced AI technologies, predictive and prescriptive analytics can be run on the data in order to gain actionable insights for the organization. Then this all needs to be infused into the blood system of the organization. So this is where operationalizing AI comes into the picture. And that's where we need to implement the AI solution to processes, business applications. And once these AI systems are already running, then we also need to keep monitoring them to make sure that they are still performing well and they are healthy. So this was like a high-level overview of the whys and the hows of AI for the organization. And now we are going to go a little bit deeper inside to see how we actually build out a workflow, a solution.
As Anna Maria mentioned, data science workflow is really like a journey. It's not only about building a good machine learning algorithm, it's really an end-to-end journey, starting from knowing which data you need for your use case and start collecting it and processing, doing feature engineering and making your data ready to be consumable by your machine learning or optimization model. And at the end, you have to operationalize that model. So now I'm going to talk about the typical data science workflow. And as it was mentioned, so after collecting the data, actually most of the time of a data scientist in real world use case and applications is spent on analyzing, cleaning data, data transformation, and feature engineering. In some surveys, actually the data scientists said almost 80% of their time is spent on this. To be able to select the right features, convert the data types, and make it consumable to the model. And then after the data is ready, then we will decide on which model is the best for the use case that we are going to tackle. Based on our use case, we can try out a couple of different models. For example, if it's an unsupervised model, segmentation, then we do clustering. If it's just grouping, or if it's grouping, or if it's supervised, we may do classification, or if the data is continuous, we do regression. So really, the type of the model that we select is really dependent on the use case that we are tackling. And even if you have the best model in the world, unless you don't deploy it and put it in production, it really doesn't bring any value. So after building your model using any tool, you have to put it into production and deploying it either in real time or in batch mode. So what I mean by that is, for example, consider some of the application like real-time fraud detection. That type of the model deployment is real-time deployment. And sometimes you want to use your model to score all the data that is stored in your Hadoop ecosystem or your data warehouse. That is called batch scoring. And once the model is deployed, we are not done yet, because as the time goes by, the nature of the data that is ingested over time may be different. The distribution of the data that is ingested may be different from the original data that you used initially to create and build and train your model. That's why it's important to keep monitoring and updating the model parameters over time to make sure that our model is accurate and performing suitable over time. As well as the other topic that we are going to cover today later in more details, it's not only about monitoring for model performance. We should also trust that model, and if we let machine learning algorithms or in general data science models that we have built to make decisions for us, then they should provide us with the decisions that we can trust. And it's not biased, or it's aligned with the regulation. So it's actually the last part is very important to maintain and monitor the model. So I will very quickly go over all these steps and provide some quick information. So as Ana Maria mentioned, most of the time when you want to collect the data resides in many different data stores. So we have data silos. A couple of years back, some concept was introduced that was called Hadoop ecosystem, which helped organizations to bring the data in one unique large chip storage and store it there, and also it provided them with a distributed parallel processing, which was called MapReduce. However, there is another concept which is called virtualization, which actually most of the time is very helpful, and it will avoid us to change and to move the data. The idea is to bring analytics to data, not vice versa. So wherever your data is residing, whether it's a structured format and stored in tabular format in relational database or data warehouse, or sometimes it's semi-structured or totally unstructured, like data from images, text data, and so on. So wherever you have your data, then the next step is to actually clean and transform that data. Some of the data transformations that are mostly used are applying some of the models, some of the concepts like one-hot encoding or changing the data type in order to have the data in the right format. For example, if some of our features are in text format, then we might want to convert them to be able to be consumable by our models. Some of the other steps are normalization, and sometimes actually when our data is so unbalanced, we might want to do sampling. Let's imagine you have a binary classification problem and most of the data resides on negative class. So the model that you will build with this training, very unbalanced training data, might provide you 100% accuracy, but it doesn't mean that that model is good. It's just because it actually classifies all the points to negative class, which actually is a correct decision. However, if you go back and look at the other performance matrices like recall and precision, and then you will realize that you actually want a model that is trained with more trustable data points. So sometimes we have to work on the input data to make sure that our model sees what we want it to learn. Sometimes also when we have text data, we do tokenization, stop words filtering or removing, and TF-IDF, and there are so many more. I just wanted to mention some. And sometimes it's very helpful to do dimensionality reduction before actually using the data for analytics, and it helps to bring the data to a dimension which the data is more representative and in better quality. Some of the algorithms that will help us with that are principal component analysis, PCA, and singular value decomposition, which help us to bring the data to lower dimension, and it's one of the data pre-processing steps. And also sometimes the opposite is helping to bring the data using some functions called kernels to higher dimensions to be able to have it in better format. So let's talk about building the model right now. So a lot of data scientists actually prefer to use open source models. And IBM and myself also, and all my colleagues are a big fan of open source. And the reason is that because there is a huge community behind the open source that contribute to the models every day. So, many of the very popular algorithms like TensorFlow, Spark, and many different available algorithms are actually have been open source, and a lot of very good developers are contributing to them every day. And IBM also has a center for open source technologies, and the website is listed here. I will show you the website quickly, but the purpose is to build some open source project and make it available to everyone to use. So you can just go ahead and download whatever project and code is there. It's just to accelerate the adaptation of AI. And one of the projects that is open source and put in this website is AI fairness, which is to detect and mitigate bias. And we are going to talk about in more details later. So in order to apply machine learning algorithms for the data at scale, there is a processing engine called Spark. Spark is actually very fast, and because of its in-memory computational power, it will help us to apply the algorithms in large scale. So many of the machine learning algorithms have already been implemented and are available in Spark library. So you don't really need to implement them using Spark concept. You just, they are ready to be used. And there are also different models implemented with RDD and at the same time with data frame concepts. And RDD and data frames are the two different data types of Spark. Data frame is based on RDD, however, it has a schema. So you can see the columns and the schema of the data set, basically. And Spark is not only for running machine learning algorithms, it actually helps us to run the distributed SQL engine. It actually has a library called Spark SQL. It has a library for graphics, so Spark Graph. And also it helps us for streaming data in real time, which is called Spark Streaming. So it's very helpful and very fast parallel processing computational engine. And it also has very good libraries and methods, I would say, for the feature engineering, especially for when you work with RDDs. The other concept is the deep learning platform. So initially, a couple of years ago, we only had access to mostly structured data, like tabular data, which was stored in data warehouses. But as the data types change over time, we had more access to data coming from social media, such as text data, documents, images, videos. Then we really needed to have some other powerful algorithms to help us tackle these problems. And deep learning getting more and more attention these days. And here you see the power score of different deep learning libraries, and TensorFlow so far is the most popular one and has most commits in GitHub. And Keras is just based on TensorFlow, but it's higher level API. So if you don't really want to go deep dive in your deep learning network and optimize the parameters and do coding, Keras is just a higher level API. So it just, most of them just depends on whether they are higher level or you can go deeper to change the model and to change the how the network is operating actually. And the most interesting thing that there was a lot of talks in recent Strata conference that I attended was the use of Spark and deep learning together. So basically you do hyperparameter optimization and tuning using Spark in a scale format so that it brings the power of Spark to your deep learning algorithms. And some of the companies that worked and talked about this and mentioned some of the packages that are available, for example, TensorFlow, Spark, you can just Google and see how it works. And it's actually very helpful to combine these two very powerful concepts. So now let's talk about AI automation a little bit. So far we learned how to build the machine learning algorithms and what are the useful packages that you can use. However, there is something that also called AI automation. For some people that are mostly citizen data scientists and maybe higher level users and more executives, or someone that really doesn't want to write code in R, Python, Scala, and Spark, or data analysts that want just to get some insights about the data, there is something called Auto AI that I also quickly show you. Is just help them to accelerate their process. We also have the same thing for neural networks. So it will automatically build in the neural network architecture and network. So and the end user doesn't have to be concerned about the coding and modeling part. So about the neural network part, I just want to mention a good and very important concept, which is transfer learning. So you don't have to start from scratch all the time and build your network from scratch. The concept of transfer learning is that the network is going to be learned and the model parameters are kind of the network architecture is built based on some training data. And then when you want to apply it to your use case, you just have to fine tune it and retrain it with your new data set. Let's say you have a use case that you want to input some images of cats and dogs so that your deep learning can classify them. You don't have to start from scratch. You can just bring a model and a network that was already trained using some other set of images and just make it suitable and retrain it for your current images, set of data sets, which is very important and useful concepts. And maybe I can talk about these concepts and the pipeline further when I will show a demo as well. So this is just a quick screenshot of the Auto AI and Neural Network Model Builder, which actually will help you and build a pipeline for you, starting from ingesting data, data preparation, feature engineering, hyperparameter optimization, up to the part that you can decide which performance metrics you want to optimize your model for. For example, area under ROC curve, accuracy, and so many other matrices that you can actually choose to monitor and do the and optimize your model for that. And this diagram shows you kind of the high-level architecture of what I discussed so far, the building the model using different open source tools, the language of choice, and then deploying of the model. As you see in the second box, when you build your model, the most important part is actually to deploy that model. And the last step is to operate that model, which is to keep monitoring your model to make sure it's always adapting to the new data and information that's ingested, and also monitoring it for fairness, explainability, which is very important feature. So when a machine learning model make a decision, it should be able to have the explainability feature to be able to explain which features or which factors lead it to make this decision, which is also one of the features of the OpenScale that I'm going to talk about, and which is a tool that actually is used to operate the machine learning workflow. So a lot of times when I talk about these concepts, then many audience ask me, okay, these are very interesting topics, and we are very interested to know the real world application and how they actually have been applied in real world use cases. So that's why Ana Maria and I decided to put some of the use cases that we have worked on and put these concepts into actual practice. So one of the customers that I recently worked with, they had some challenges about identifying the parts needed to fix the problem. So based on the ticket and alarms that were ingested and were mostly in text format, the goal was to predict the parts needed for the fix. So in this case, we use historical information and we built a multi-label classifier to tackle this problem. And so whenever the ticket with multiple alarms was ingested, then the parts that needed for the fix with certain probability was kind of printed so that they know which parts should be actually sent to fix the problem. And there are some other use cases that Ana Maria is going to cover.
Yeah, so the next two use cases I wanted to introduce you to are for the financial institution Nedbank, who are based in South Africa. So for Nedbank, we had two use cases. One of them was focused on the ATM and ATM experiences of their customers. What they wanted to achieve is that when a customer walks to an ATM machine, they find fully functional ATM machines at all times. Okay, so what can go wrong with an ATM machine? First, it can run out of cash, or it can have some sort of failure. So our task was here with the data science elite team to build out predictive models with machine learning to predict both of these events. So when the cash machine would run out of cash, or when it would be faulty, and what the fault category would be. And then based on that, we could also do some scheduling to enable the technicians, the maintenance technicians, to visit these cash machines and do the necessary maintenance work. So with that, Nedbank could eventually help the customer experience by reducing the number of faulty machines and also reduce their own costs for the with the timely maintenances, and also avoiding some loss of revenue as well. And on the next slide, we will have another use case for Nedbank, which is a fraud detection. So in that scenario, our job was to do a classification with machine learning and to distinguish which bank transaction was a real transaction made by the Nedbank customer and which one was a fraud transaction. And by doing so, when the model predicted that a transaction is potentially a fraud transaction, then it could actually help Nedbank to make the necessary actions immediately. So it could assist the fraud responders to actually respond faster to these fraud alerts and make the actions. And on the next slide, we have another use case for Carrefour, which is a retail organization in France. They have a lot of supermarkets all over in France, and their problem was to figure out where to open the next location, the next supermarket. And to do so, they wanted to use predictive analytics and predict where, how much would be the annual revenue of the new locations. So what we did here was, again, with machine learning, we did predictive analytics to predict not only the annual revenue for the new markets, but also for the existing supermarkets as well. So with that, Carrefour could actually make a decision on what's the best location for their new stores. And with that, they could achieve higher profits with better store investments as well. So these were some high-level overviews of some of the data science elite teams' work that we did with our customers. And now, in the next section, then we are going to speak about the AI challenges. What are the challenges that we are facing? So on the next slide, at first, I wanted to introduce you to one of the 5 predictions that IBM made for the future. And this one in particularly speaks about AI bias. So it says that within 5 years, the number of biased AI systems and algorithms will increase, but only the unbiased AI will survive. So this is technically a call for action for us as well, because we need to come up with new solutions in order to control bias and mitigate it. Now, on the next slide, let's have a look at this bias or this problem, or what the challenges are with regards to bias. So we often say that AI is biased, but maybe we should step here for a moment and think about it. Is it really AI that is biased at the first place? Or is it us, human beings? So just let me just think about and explain the logic for this sort of question. So if you think about how an AI system works, so it is fed by data, and then the AI system recognizes the patterns and characteristics within that data, and then from the knowledge that it gained from it, it will apply it to previously unseen scenarios and make some decisions. However, that historical data that the AI system uses often reflects past decisions of us, humans. And therefore, it effectively reflects our biased decisions that we made, humans. So effectively, the algorithm actually holds a mirror for us, showing our own human biases. So, okay, but how does bias eventually make it into the AI system? So on the next slide, I will probably elaborate on this a little bit further. So according to research, there is more than 180 biases, human biases classified, which can be, some of which can be actually detected in our AI systems. So as I mentioned previously, the many AI systems are trained using the biased data. And then the biased model often prescribes a more favorable outcome for one group of people than to the other. And this can be bias for race, gender, age, ideologies, or other biases. So eventually we can say that AI systems are only as good as the data we put into them. Now, on the next slide, yes. So as I mentioned previously, AI actually holds a mirror for us humans to reflect on our own human biases. But we can actually capitalize on this and make a use of it, because AI could potentially hold a key to help us mitigate that bias by alerting us to our existing biases. And recognition of this is already the first step towards resolving the problem. I'm sure that most of you have already heard about a lot of studies that have been conducted recently, probably in the last years. And there have been a lot of multidisciplinary conversations about AI bias, and also at conferences and conventions as well, there are a lot of discussions about AI bias. And by progressing new ethical frameworks, and just by simply critically thinking about all the bias that we actually make, that can already accelerate our journey towards bias-free artificial intelligence. So on the next slide, then we will speak a little bit about the regulations on the horizon.
So with the extensive use of AI, due to the increase of AI adaptation, and since we have access to more predictive and prescriptive AI and many contributions that is like a lot of people are making every day, and the chip processing systems that are available to us at scales, and the more access to different data sources, and all of these actually have led to accelerating use of AI through different industries, in healthcare, in financial organization, in mobility, social media, and also in criminal justice systems as well, which actually I'm going to give you an example of. So with increasing of adaptation of AI, it also increases the probability of unintended consequences and potential harms. And regulation will actually help us to address these concerns and hopefully to find a solution for this. So this is just the statistics of how important it is when something happens through the mistake that a machine learning algorithm can make, or AI in general. And through a survey, 80% of people in the organization thought that this concept will be extremely important and mandatory and a priority to be discussed in their organization. So they think regulation and ethics is actually one of the top of the list in their organization to discuss in near future. And as you can see, since 2000 specifically, we have a lot of growth in technology, because since then we have access to big data processing engines. We have learned how to collect and process data from many different sources like social media, IoT, and the cloud computing also has growth in these couple of past years. However, unfortunately, the regulations like security, ethics, trust, rights, these things did not grow as the technology grew in the past couple of years along with it. So the laws for humans is in place. So when a human make a mistake, we know we have some rules and regulation in place how to deal with that. But what if an autonomous driving vehicle actually have an accident and kill someone? Then who and what determines whose responsibility it is? Is it the actual driver because usually they put some driver to control in case AI fails? Or is it the machine learning algorithm fails? Or is it the data scientist that actually developed the model, or is it the CEO of the company? So really, who is to blame? Or another critical scenario is for healthcare. For example, for cancer screening and liability for malpractice, or for example, when we do collection of data and when there is a potential bias in treatment data sets that we use to detect and cure the patients. And in financial sector as well, for example, there are some cases that they realize there is some unintended bias in credit lending. And I will show you an example. Let's say, especially they realize it's in gender bias when there were some female that were applying for credit or loan, they were rejected. But if only the gender was changed to male with the and the other features such as employment history or the number of years of work and some other features stayed the same, then the person get approved. So I'm sure none of you like this decision. It's actually very biased to the gender. And for example, as Ana Maria mentioned, one of the problems is mostly based on the data that is fed to the machine learning algorithm. Let's say if we don't have enough training data set on females that have requested to get loan, and also the ones that were not qualified, maybe they didn't have work history and so on, then our model actually get very biased, and we should find a cure to this kind of problems. So 60% of companies or business stakeholders, I would say, see the regulatory constraint as a barrier to implementing AI, which is actually a very interesting number. And just to give you another example, just to really sense the importance of this concept, many years ago, for the justice system, they actually tried to use a software that was called Compass. And this kind of automated system helped them to score the criminals and decide whether they should be freed or they should be kept in jail before the actual trial day. And unfortunately, because of the training data set and the bias that was introduced unintended to the system, they realized there was a bias in the decisions and scores that the model gave. And how they realized it, because after they evaluated the scores and the history of the people, they manually scored it, they realized that many of the scores were unfair and based on the training data and the bias that was introduced unintentionally. However, it was detected afterwards. And director of policy research at AI Now Institute at New York actually mentioned that it's in conversation around AI, people always talk about the list of pros and cons that it provides to us. But that's a moment of power and privilege to be able to determine that it's okay that some folks are disappropriately harmed. So it's really important to eliminate these type of biases from our algorithms if we really want to put them in production and also trust the decisions that they make. And also Joy from MIT Media Lab said that we have entered the age of automation, overconfident, yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equality. So as you see, it actually affects a lot of different population, and it's not only about the specific ethnicity or gender. It can actually happen to anyone if we don't monitor and keep an eye on our machine learning algorithm. So far, I just talked about the potential harms and risks that it provides. So really, what's the solution and how we can combat the bias in our AI algorithms? So a lot of organizations and institutions have decided to include ethics topic in the courses, in computer science courses that are offered in these universities. Some of them are like Harvard, MIT, Stanford, Cornell, and University of Texas, because they realize that the people that are learning to build these algorithms, they also have to learn about the ethics so that they kind of build these models and algorithms with having these concepts and learn about them. So the overlap of having a model that is technically feasible, it is legal, is desired and ethical, is actually the right decision that organization would like to achieve. So, and we should make sure that all of these are checked and are valid for the decisions that have been made by our automated systems. So IBM has actually put a lot of effort recently to build some of the tools that actually helps organizations and people in this domain. Some of the tools to combat bias is actually AI Fairness 360, which is an open source library for metrics to help examine, report, and mitigate discrimination and bias in machine learning models through the AI application life cycle. It's not only for the model in production. However, as the diagram that I will show at the end, it will keeps monitoring starting from the data that we'll put to the machine learning system until the last part, which is putting model to the operation. So IBM has actually open sourced this library and made it available for everyone to use. And there is another toolkit which is called Watson OpenScale, which is more suitable towards the production. When you put the model in real production, then you might want to consider Watson OpenScale, as it's kind of like more completed version of AI Fairness 360, and it has some other extra capabilities like model explainability that I was talking about earlier, where the machine learning algorithms are able to explain the reasons and features and factors that they considered and how they came up with the decisions that they came up with. So this is the diagram I was talking about. So as I mentioned, the bias can happen in any part of our process, starting from where we do data pre-processing, data selection, or when in process when we design the algorithm, or in post-production. So AI Fairness 360 that you will have a chance to play around with, we will provide you with the links, actually will help you to mitigate and fix this problem in early stages, pre-processing and in processing. And Watson OpenScale will cover those as well as in post-processing as well. And I just put this high-level architectural diagram to show you an end-to-end process of how actually AI Fairness 360 and OpenScale, or in general, a tool that is used to combat bias, can be used in the whole ecosystem. So as you can see in the beginning of this architecture, the data scientists use some open source tools like scikit-learn, TensorFlow, Spark, and so on to build a model. And once the model is built, then the data scientists can actually use AI Fairness 360 to just test and mitigate the bias if it exists in the algorithm, as well as test if the data that he or she used to build the model was biased, and then debias the model. And when the model has been put into production, as shown in the bottom right of the picture, then OpenScale will take it from there and actually monitor and manage the model in production and mitigate the bias if there is any. Because maybe there isn't any bias in the initial training data set, but as the new data ingests, it may actually introduce bias and make our model diverge from its original trust and transparency.
Okay, now I wanted to speak a little bit more about the research and the research background itself regarding AI Fairness 360. So IBM published the research last year around October 2018. And as for the background, there are already so many research studies out there. So fairness research is a very active field right now. And there are a lot of fairness definitions, metrics, how to measure it, a lot of different algorithms as to how to handle the bias. And sometimes it's difficult even for us practitioners or the researchers to figure out which technique is the best in which particular situation. And that is where AI Fairness 360 research came into the picture, because with this research, we could actually promote deeper understanding of AI fairness, the metrics, and the mitigation techniques. And the research actually summarized previous research findings and built everything into one open source toolkit, which the practitioners can use as well as the researchers. So the outcome is this AI 360 toolkit that Seppi described before, which is the first system to bring together bias metrics, mitigation algorithms, bias metrics explanations, and industrial usability. And it builds upon more than 71 bias detection metrics and 9 bias mitigation algorithms. And it's all pulled together under one single umbrella into an extensible architecture. And we also encourage you, if you have probably done some sort of research regarding AI fairness and you would like to contribute, then you can always add your research findings to this open community toolkit. So if we go on to the next slide, then this shows where you can actually find about AI Fairness 360 Toolkit. So this is the website that you can follow, or maybe if you just type AI Fairness 360 into your search engine, then it will pop up for you. So I would definitely encourage you to have a look, especially that now I'm seeing that there are some questions in the Q&A section as well regarding what's the best sort of tool or mitigation technique to use. So this one would definitely help you find some answers. And also if we go on the next slide, then that will show the demo page. So we have about 4 data sets uploaded already into our UI. And one of them is the Compass, ProPublica data set, German credit scoring, and 2 more. So you can actually train a machine learning model there. And after that, you can measure the bias, and then you can pick a bias mitigation algorithm. And when you pick it, you can also find some explanations what these are for and what they actually do. So this is a very good start if you are interested to learn about AI fairness. And on the next page, you can, here actually you can see our GitHub address as well. So this is where our public repo is. And again, if you want to contribute with your findings, you can do so. In fact, after IBM published the AI Fairness 360 last year, within 1 week, we already had 1 contributor who added the 10th bias mitigation algorithm. So thank you for that person, and we would like to hear your contributions as well. And you can also join our Slack community if you have further questions. And if you need more help, then we are here to help the IBM Data Science and AI Elite team. We are an international team of data science and AI experts and practitioners, and our aim is to help organizations to proceed on their journey towards AI. So with that, thank you very much for your attention, and we are open for questions for the remaining 4 minutes.
Great, thank you both so much. And I'm just checking, I want to maybe prioritize some questions that are directly related to the topic you presented on today. For those of you who need to leave in a few minutes, feel free. The recording will be sent out, so you can see the questions and answers afterwards if you do need to leave. We have one question here that asks, what kind of experiment design would you recommend to minimize bias introduced to our AI models by raw data?
Yes, I think that was probably one of the questions I briefly touched on.
Okay.
So if you visit our website, then you can see a lot of different mitigation techniques. For example, you can have pre-processing, in-processing, and post-processing mitigation techniques. You can do reweighing, optimized pre-processing, adversarial debiasing, and reject option-based classification. So yeah, I think our website would definitely give you some more detailed answer on this one.
Have there been any machine learning programs written with ethics coded into them?
Sorry, say that again. Have there been any?
Have there been any machine learning programs written with ethics coded into them?
I think that was the topic that Sapi touched on.
Okay.
I don't know if Sapi is still.
Yeah, so am I on? Yeah. So actually there are 3 steps that we can detect the bias and introduce the ethics and regulation. One is pre-processing, one is when we develop the algorithm, and like in process, and one is post-processing. So maybe it's not exactly in the machine learning algorithm itself, but for example, both AI Fairness 360 and OpenScale help to do this process also in processing, which means when the algorithm is actually designed.
Great. And when we talk about trust and transparency, blockchain is a nice way to think about it. Is it possible to apply blockchain technology to detecting model bias, finding patterns, and targeting the wrong training set, for example?
So I believe blockchain, usually it's a good tool to kind of know the lineage, like where everything is come from. But I think the topic of our today's talk was mostly for the machine learning algorithms that are kind of maybe already built, or in any process of building that machine learning workflow, we wanted to detect and mitigate the bias. But maybe, I mean, I believe that concept can be considered and used, but I don't think that it's already been considered for the tools that we have talked about in today's talk.
Again, I'm not sure if this is something you have knowledge on, but right now, are regulatory bodies being created at the government or corporate level, or is the issue only brought up by quote unquote grassroots concerned researchers so far? And the question is being asked since it hurts business interests.
Sorry, so the question is how to actually introduce the business and the rules in the system?
The question is, are there regulatory bodies being created at the government or corporate level, I think, to monitor for bias in AI?
I'm not sure about that. So actually, I presented this concept in a conference, and actually, I received a similar question of how we can actually use and how we can define these bias concepts in our organization. So I think for each organization, really, it's case by case different. It depends how they introduce bias, because something that may seem biased to me may not be in the eye of another person. So, and it depends how they recognize and mitigate bias today. So these are just some of the tools that help them automate this process and capture some of the biases that we may not even realize when using AI in production level. But I mean, it depends whether they want to use actually data science and AI to make these decisions for them. Then these tools will help them to actually recognize and mitigate the bias and provide them with trust and transparency.
And do you have time for a couple more questions?
Sure.
Okay. It seems that the right way to fight bias is to code ethics into the algorithms instead of pattern recognition. Has there been any work done in that respect?
I think in terms of mitigation, it's a little bit complex. So it's not only in the patterns, so it's also the data, the patterns, and also how you actually pose a question. Like, for example, you can already ask a wrong question from an algorithm. If, for example, there are 3 possible decisions in real life that the algorithm can make, but you choose the algorithm in a way that it can only make decisions about 2. So you already introduced a bias there as well. So it's not only the patterns and the data. So that's why we actually separate between pre-processing, in-processing, and post-processing in terms of bias mitigation.
Yeah, and sorry, Laura, if the audience can keep posting their questions, we would be happy to take their questions also offline, because I know we ran out of the time, and we try our best to respond it on the community webpage.
Okay, that's great. Thank you. So I appreciate you offering to do that. So for those of you, since we are over time now and want to be respectful of everybody's time who's joined us today, we will go ahead and invite you to share your questions that were not addressed today, that maybe you asked but we didn't have time for, or if you have additional questions that you think of, please go ahead and post those in the Coursera community post, and I'm going to paste the link to that here in the chat box. I will also send it to you in a follow-up email, so don't worry if you don't catch it right now. The one thing that I will maybe ask quickly is, somebody has said they're looking through the IBM Data Science Elite community site and they don't see a link to the Slack community. They're asking, did I hear incorrectly that there is a Slack community as well for the IBM Data Science Elite team?
There is a Slack community. Oh, for the Data Science Elite team. That was for the AI Fairness 360 community.
Okay, great. So there's a Slack channel for the AI Fairness.
Yes.
Okay. And is there a link to that in your data science?
Yeah, and I actually had that on the presentation. So
okay.
If we are going to send the presentation out,
yes,
to participants, because if so, then they will be able to see it. So it's aif360.mybluemix.net/community.
Okay, great. Yeah, it would be great to send out the slides afterwards. So thank you for that.
Okay, great.
Okay, so thank you all so much for attending, and I just want to say again that this is being recorded, and I will be sending an email in the next few days, so you can access the recording, you can access the slides. You can find more information in the Coursera community about this event, and I will also mention that Seppi and 2 of her other colleagues from the Data Science Elite team will be hosting a Q&A in the Coursera community in the next couple weeks. So it's more about kind of the journey to being a data scientist, and you are welcome to post questions in that Q&A thread as well, and I will include a link to that for you as well. I actually will paste it right now in the chat box for you. So thank you so much, Seppi and Anna Maria, for taking the time to talk with us today and share your experience and knowledge. Really appreciate it. And I look forward to seeing everybody, hopefully, in the Coursera community.
Well, thank you.
Thanks, Laura. Thanks, everyone, for attending.
Bye, everybody. Thanks.